First thing I want to mention, somebody earlier today asked me a question. They said, Mr. Dewick, I'm not always sure when I need to add the radius of the Earth or the planet, or when I can just use the number that they gave me. So let's talk about that. First of all, let's use this fancy schmancy, change shape to, nice. So let me give you an example. Let's look at our energy equation. So potential energy is negative big G, big M, little m over R. Annika, over what? What's the R stand for? It stands for radius, which is the distance from the center of the circle to our satellite. So if the question uses the term radius, or if it says something like from the center, I can just use the number that they gave me, don't need to add anything to it. What word would I use to describe that distance from the planet surface out? If they use the word height or altitude, then I have to add radius of the planet so that it's an actual radius distance from the center of the planet. So everything has to be from the center of the planet. So altitude or height, which I've done sometimes, I think there's probably going to be one question on the test where I'll give you an altitude just to make sure you're reading carefully. I'm not going to do that a bajillion times, though, because it's just irritating to always have to add whatever the planet was. Okay. Is that all right? Answer your question all right? Okay. So let's look at this. Hey, radius. So I don't need to add anything to that. If they had said altitude, I would need to add Earth 6.38 times 10 to the 6th to it. Once the orbital speed, we're in orbit. Oh, sorry, I can just see I disappointed so many of you. My bad. And Circe. Okay. I can say gravity is what's pulling me in a circle. Now, if you've done enough of these that you've inadvertently memorized the punchline, if you go straight to the punchline, I'll be fine with that on the test. But just in case you've forgotten, my next step would be big G, big M, little m over R squared. That doesn't change at all. Hey, everyone, look up. This is the force of gravity. Everyone look up. What's that? You kind of need to know this. That's gravitational field strength. That's little g, right? That's why I gave you an equation for little g. It's the force of gravity with the little m canceled out. That's the 9.8 on the Earth, but that's the whatever you are anywhere else. Just a little, refreshing your memory kind of dealio. This equals m. I guess they said speed, so I'm going to use that. Definitely a little m cancels. Pausing for a second as latecomer number 1 strolls in. So a little m cancels, and again, that's handy. Was there somebody else just about to show up too? So now I got to pause again. On your test, I'm definitely going to give you an orbital question, and I'll tell you right now, I'll give you one of orbital speed, orbital radius, orbital altitude, because if you know the altitude, just add the radius of the planet and you've got the radius, or orbital period, and I'll probably ask you to find 2 of the other ones. I'll do a part A and a part B. There's a really, really good chance I might do the one that requires you to hit your cube root button. Why? Because it requires you to hit your cube root button. And how does that not make my little math nerd heart go pitter-pat? Which one was that? I don't know. I'll let you look at your notes. Meanwhile, here, also one of the R's cancels. Oh yeah, and square root. So for those of you who got here late, I said if you happen to have memorized this punchline, I'm fine if you go straight to the punchline, but here's the derivation. So we're going to get V orb equals the square root of big G, big M over R. And now if I plug in numbers, big G, 5.98 times 10 to the 24th all over 8.1 times 10 to the 8th. 10 to the 8th is way out there because the Earth's radius is 10 to the 6th. We've done some where you're 10 to the 7th. The 10 to the 8th, this is way out there. This is probably going to be a slower speed. It might not even be in the thousands, or if it's in the thousands, I think it's going to be in the low thousands. Not that I know what the answer is. Let's see. 6.67 times 10 to the negative 11. 5.98 times 10 to the 24th divided by 8.1 times 10 to the 8th, square root of that. Oh yeah, there you go. We're far enough out there. Gravity is weak enough out there. We don't need to go that fast. We didn't need to give this particular satellite much kinetic energy, but we had to give it a huge amount of potential energy to get it there. If you actually play with the numbers, you'll find it still costs way more fuel than keeping things in close. It's why typically low Earth orbit is the choice. 702, is that right? 702 meters per second. If you got that right, 2 out of 2. I would probably make this worth 3 or 4 marks on your test, but otherwise, for marks, I would go half mark for that, half mark if I saw that, half mark for the numbers, and a half mark for the answer. What's the kinetic energy? Oh, okay. That hasn't changed. A half little m v squared. So it's going to be 0.5 times 2,500 times, all right, 702 squared, but you know I'm going to use my answer button. 0.5 times 2,500 times answer button squared. Do you get 615? That 6.16 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. Look up. What's this satellite's potential energy? Times by 2 and make that negative. That's its potential energy. What's its total energy? So it would be that there, make it negative. What's its total energy? This divided by 2, which is the same magnitude as the kinetic, but negative. You can survive just fine without that, but that's the pattern that I was mentioning the other day. Oh, now it wants me to find an orbital radius. They gave me periods. So again, we're in orbit. Gravity is what's pulling me in a circle. Big G, big M, little m over r squared equals m 4 pi squared r over t squared. Little m still cancels. I'm going to get r cubed equals big G, big M, t squared over 4 pi squared. So I guess it's going to be the cube root. Going to be a lot of typing. R equals the cube root of big G 5.98 times 10 to the 24th, 2.4 times 10 to the 4th squared, all over 4 pi squared. My cube root button is math cube root. Bracket 6.67 times 10 to the negative 11, 5.98 times 10 to the 24th, 2.4 times 10 to the 4th squared divided by, I need another bracket, 4 pi squared. Close off the bottom, close off the cube root. Make sure I didn't make a typo. Did you all get 1.80 times 10 to the 1, 2, 3, 4, 5, 6, 7? 1.80 times 10 to the 7th. Annika, what if just for giggles, instead of asking for the orbital radius, I asked for the altitude? This is from the center of the planet, so if I went minus 6.38 times 10 to the 6th. That's its altitude above the planet. That's what's left over. But I'm going to go back to my answer, plus 6.38 times 10 to the 6th, because I think I'm using this for part B. What's the gravitational potential energy of this satellite relative to 0 at infinity? Why do I say relative to 0 at infinity? Oh, for 2 marks, by the way, I would probably go like this. Half mark if I saw that, half mark if I saw that, half mark for the numbers, and a half mark for the answer. Why did I say relative to 0 at infinity? That's my way, Deegan, of saying, please make sure you use cosmic. You can't use MGH. What's the cosmic one? Negative big G, big M, little m over R. It's going to be negative big G, 5.98 times 10 to the 24th. What was little m, Mr. Dewitt? 1200. All over, and this is going to be my answer from part A. So if you got part A wrong, but you used it here, I will give you full marks for this. Negative 6.67 times 10 to the negative 11 times 5.98 times 10 to the 24th times 1200 divided by, oh, I made a typo, Mr. Dewick. Go fix your typo. This is why you always check. Insert a period. 6.67 times 10, 5.98 times 10, that looks good. Do you get negative 2.66 times 10 to the 10th joules? What does that mean? It means if I want to escape Earth's gravity, if I want to get out to 0, I have to add that much more energy in terms of rocket fuel. That's what also that's telling us. Yeah. I would take off a half mark, and then I would draw a big frowny face, or I might draw a physics teacher weeping, or maybe a kitten looking at you with big eyes and just a little why coming out of it, something like that. Negative 2.66 times 10 to the 10th joules. And again, that's really also what it means relative to 0 at infinity. It's saying to escape Earth, you still need to burn that much more rocket fuel energy. Is that a lot? Yes. Is that why it's expensive to go to space? Yes. A few of you have asked me questions. Actually, honestly, the best spacefaring race would be if somehow on a much smaller planet with less gravity, intelligent life evolved. Even better if they weren't on average about 1.8 meters high, but if they were also really tiny and had small masses. That would be a good spacefaring race. They would have a lot fewer issues than we have to challenge with. So maybe the first intelligent spacefaring life that we find will be small. Be easier. How much work? Okay. Lifted. Are we in orbit? Oh. There will be a question on your test where we just lift something up and I say, how much work? So what does that mean? I start out by going work is change in potential plus change in kinetic. But because we're just lifting up, I can ignore that. Compare that with, oh, I didn't ask a number 4. I was going to say compare that with number 4, which puts you in orbit. That'll be on your next take-home quiz. If you're in orbit and I say how much work, you can't cancel that out. There is a change in kinetic. But if we're just lifting it up, we're going to let it fall back down. This is just asking how much fuel to get it to the correct location, correct height. And Annika, altitude. I'm going to have to add the radius of the Earth to that. What's change in anything? Negative big G, big M, little m over R final minus negative big G, big M, little m over R initial. Negative big G. Are we Earth? Okay. I think on your next quiz, just for giggles, we'll do the moon on one question because I dream. 5.98 times 10 to the 24th. 6450. All over. Our final is going to be, Annika, the altitude plus the radius, because all they gave me when they gave me the altitude was that distance. And I need that distance for my equation. Is that okay? And then minus minus, which is a plus, same thing times same thing times same thing, divided by, and I guess we're just starting out on the radius of the Earth. Okay. Now we find out if you've had enough practice typing these. Negative 6.67 times 10 to the negative 11 times 5.98 times 10 to the 24th times 6450 divided by bracket 4.6 times 10 to the 5th plus 6.38 times 10 to the 6th. Is there a squared on r in this equation? There is in the force equation. There is in the gravitational field equation. Oh, but sometimes when you're doing gravity is what's pulling me in a circle, sometimes an r will cancel. Sometimes you'll get an r cubed. Negative 37612 times 10 to the 11th. Negative 37612. Negative 3.7612 times 10 to the 11th. Plus negative 4.0324, negative 4.0324 times 10 to the 11th. Not negative, Mr. Dewick. I forgot to delete the negative. Silly me. Let's do that again. Don't forget to nuke the negative, Mr. Dewick. There we go. And so now I add these together. So it's going to be that negative 3.7621 times 10 to the 11th. Sorry?
You wrote one instead.
I wrote 1, 2? I think it was. Did I wrote? It is 1, 2. I said 1, 2. I said 2, 1. Anyways, there. I think that's right. Plus, you can see it's easy to make mistakes. At least mine was on the 4th sig fig. I might have gotten away with it. You get positive 2.71 times 10 to the 10th? If you got that right, I would give you, what did I make this worth? 4 out of 4. Otherwise, 1, 2, 3, 4, 5. I would probably go something like this. Half mark if I saw that. Half mark if I saw that. I would probably give you a half mark for those numbers if you'd remembered that you had to add the radius of the Earth. Half mark for that. That's 1, 2. I'd probably give you a half mark if I saw that number, a half mark if I saw that number, and then 1 mark for adding them together or something like that. Can you give yourself a lovely score, please, out of lucky number 13? Any lawyering with me? Now is the time.